it's raining so much rain. I can barely see you. Oh. And then rain can just stop like that. You know, that's something I really don't understand is the weather. Like, why can it rain in Garson but not in Coniston? Or why is it raining on Science North but not at Dynamic Earth? So many questions about weather. I don't know what to do.
Don't worry, Jen. I'm here. I think I can help.
Hey, Amy!
Hey, Jen.
Amy is a staff scientist here at Science North. I know you can help me, Amy. I know that you know a lot about weather.
I sure do. Weather science is one of my favorite things to study. So why don't we go take a look more at it?
Sounds great. It looks like I'm about to learn some stuff.
Hey, Amy, is it nap time? Not quite, Jen. But I wanted to bring you out here to show you this.
The sky?
Absolutely, but in particular, those white, fluffy things up in the sky.
Oh, I know about those. Those are clouds.
Absolutely, but do you know how they're formed or how they're made?
Oh yeah, you know, everyone knows that a cloud is made of that white marshmallow stuff.
Wow, that would be very tasty. Not quite. But in order to make a cloud, you need two different things. What do you think they'd be?
Cotton balls and gray paint.
That would make a really good homework project. But in order for a sky, we need water. First ingredient, very important. And we also need dust in the air, which is kind of a weird ingredient that we don't think of too much. So as water evaporates off the surface of our planet, it changes from a liquid to a gas. So water, vapor. And as it changes into a vapor, it goes up and up and up into our sky. And it meets up there two things. Cold temperatures. It gets a lot colder up in the upper atmosphere. And it also meets up with pieces of dust. And what's really neat is that as that water vapor cools, it gets attracted to those pieces of dust. And yeah, it's really neat. And then around those pieces of dust, the water droplets that have now changed from a gas to a liquid as it's gotten colder, they kind of meet up together around that piece of dust. And more molecules can join in, and all of a sudden, you've got a water droplet. And it's the water droplets that we see, which is really neat because our clouds are not made of water vapor. They're made of liquids, and sometimes, if it's cold enough, even solids.
That's amazing.
And what do you think what happens when that droplet gets big enough, Jen?
It rains! Hey, Amy, I was wondering, what's the difference between fog and a cloud?
Oh, that's a really good question. There actually isn't that much difference between their makeup. It all depends on exactly where they are in the Earth's atmosphere. So something that's really low to the ground, like if we felt like we were moving through the cloud, that would be fog. But if it's higher in the atmosphere, that's when we start calling them clouds. They're both made up of the same thing though. Water vapor that's been condensed into water droplets.
That's really cool. Another question, Amy. Are clouds cold or are they hot? Like, what's their temperature?
Well, guess what I brought with me, Jen? We're gonna do an experiment. So I brought with me a laser temperature gun, and we're gonna take some measurements of both the clouds and the sky to give you an idea exactly what is the temperature of clouds. Now, a cloud lower to the ground will actually have a higher temperature versus something that's higher in the sky will have a lower temperature. So let's take a look and see if that's right.
Okay, I'm excited.
So let's use our temperature gun to measure the temperature of these clouds. I'll choose this cloud right here. So we have a temperature of 2 degrees Celsius for the cloud. But let's take a look at the sky. Up in the sky, it's minus 27.6. That's a huge difference. It's amazing. The further you go up in our atmosphere, the colder it gets, and the more likely our clouds are going to freeze.
Wow, that was really neat.
Absolutely. And you know what else is really neat? Clouds have all kinds of different names.
Oh, like you and I. Oh, is there a cloud named Jen?
Probably not, but if it was, I'm sure it would be full of sparkles and glitter.
Me too.
Depending on what the cloud does, depending on what the cloud looks like, and where it ends up in our atmosphere will tell us what kind of cloud that is. And it all have different names. So some clouds maybe are closer to Earth, some clouds may be somewhere in the middle of the atmosphere, and other clouds might be higher in the atmosphere. But my favorite cloud expands all three. It starts low and towers high up into the atmosphere. It's called a cumulonimbus cloud, and that's where thunderstorms form.
Do we get to talk about thunderstorms?
Yes, we do.
Wait a minute. If we're gonna talk about thunderstorms, doesn't that mean we're gonna talk about...
Oh, right! My favorite things about thunderstorms is lightning, which is why I've brought you here. So we've got some amazing, interesting ideas about how lightning is formed, but the reality is that this is still something that scientists are trying to discover. So we don't know as much about lightning as we'd like to, but we do have some pretty good theories about how it forms.
Cool.
So let's take a look at what goes on inside of this big thunderstorm cloud. So a cloud like this has a lot of what we call updraft. There's lots of warm rising air that's going way up into our atmosphere. It cools down up here and freezes the water. So you might end up with small particles like a snowflake, or you might end up with larger particles like a hailstone. Now, I'm sure you've seen hail fall from time to time during a thunderstorm. But hail can do some really cool stuff. So as hail is dropping through the thunderstorm, it might actually hit these other little smaller particles, these other snowflakes and small ice particles that are around it. Now, all atoms on our planet have something that's a part of them that's really neat. They're called electrons. And electrons can be given away to other things. And this is what scientists think is what is happening in a cloud, is that the snowflakes are basically giving electrons to the hailstones. And as the hailstones drop through the cloud, the bottom part of our cloud becomes negatively charged. And now the top portion of our cloud becomes positively charged.
Oh, wow. Okay, positive and negative.
Now the stuff that's here on the ground, things like trees or buildings, or even people, which is why thunderstorms can be dangerous, they can develop positive charges. So you might have things that have a positive charge here at the ground. Now, when lightning begins to occur, it's a really neat process when it starts. This negative portion of the cloud begins to send out kind of like little electrical feelers. There could be hundreds of them just coming down from the cloud like this. And they're called step leaders, and they look just like stairs. They're jaggedy and they're trying to find their way to something. And what are they trying to find their way to? They're trying to find their way to something that is positively charged because they're negative, and positive and negative things attract. So neat. So laders will actually come up from positively charged items too, and they're trying to find their way towards the negative charge leaders from the cloud. Where the magic happens, and this is really neat, is when a negative step leader reaches a positive one and they connect. And electricity then zooms up back here in something that we call the return stroke of the lightning strike, and that's the lightning that you see outside during a lightning storm.
That is some shocking information you just gave me, Amy.
That's a really bad joke, Jen.
Thanks, I worked hard on that one. Hey, Amy, that brings me to my next question. You just explained lightning, but what about thunder? Is it really just Thor dropping his hammer?
Not exactly, but to explain this one, let's go back outside.
That was quick.
It is. Lightning's really neat in that it's actually really hot. In fact, it can be up to 30,000 1,000 degrees Celsius.
Whoa, that's way hotter than me.
That's way hotter than 5 times the surface of the sun, Jen. Not just you. And the amazing thing about that lightning being so hot is that's how it creates thunder.
Wait, if you're telling me that lightning is what creates the thunder, how come I hear or I see the lightning before I hear the thunder?
This is really neat. Light travels a lot faster than sound does. So when you see a lightning strike happen and you hear the thunder afterwards, it's because the sound wave that lightning is making is taking longer to reach your ear than the light does to reach your eye. So imagine this. You've got a lightning strike that heats up. It's so hot and it heats up the air around it. That air, like all air when it gets hot, expands. And it expands so fast that it creates a sound wave. And by the time that sound wave reaches you, that's the crack of thunder that you hear.
So when I hear thunder, should I probably go inside?
Absolutely. So as soon as you can hear thunder, that storm cloud is close enough that you could actually be hurt by that lightning. A lot of people too, they like to figure out how far away is the storm from the lightning strike. So here's a little trick for you. If you see a lightning strike, start counting. For every 3 seconds that you count, that storm is that many kilometers away. So if I count 1, 2, 3, the storm, that lightning strike was a kilometer away.
Oh wow, that's really good information. I remember my grandmother used to tell me that every time we were sitting and hearing storms happening and counting, and that's how far it was. So it's a truth.
It's a truth.
Awesome. You know, Amy, another thing I don't understand about storms is this. Well, like, usually when there's a storm here in Sudbury, it comes along with kind of high winds. Why is that? Where do those winds come from?
Well, it's all about how air moves.
Does it move like this?
Well, not quite, Jen, but I love your interpretation. So air moves in a cloud kind of in an interesting way. As warm air begins to rise from the ground, it cools in that upper atmosphere. And as it cools, it falls. And that falling of air is what we call a downdraft.
So it's the up and down moving air that kind of creates that wind?
Absolutely. Within that storm cloud, for sure. Now, sometimes that up and down moving air can be really, really intense. You can imagine air moving up, warming, then cooling off and moving down, but then more warm air pushing it back up into that cloud again and then coming back down. If that happens a whole bunch of times, that moving air that's coming back down could turn into something called a microburst.
Oh, but not all storms create microbursts, right?
That's right, and thank goodness for that, because microbursts are intensely strong winds. They can be almost as intense as a tornado.
So, Amy, now that you've taught me about lightning and thunderstorms and things, I have another question. How do we predict this type of weather or storms or things like that?
That's a great question, Jen. Meteorologists are the scientists that study weather, and they take a whole bunch of things into account. They measure our weather every single day through instruments across the country and around the globe. They also use things like satellites in outer space, radar, and all kinds of imaging systems to help predict the weather. The most important thing, though, they use is math. And those mathematical models that they build help us predict whether it's going to rain today, tomorrow, or if it's going to be a sunny beach day. Isn't that amazing?
That sounds simple enough.
It's not as simple as you think, Jen. A lot goes into our weather forecast. That's why 1 minute you could be experiencing one weather, and in the other minute, a totally different type of weather. Morning forecast could change in the afternoon. It's really an interesting science.
Oh, so that's why the weather can change. When you check your weather app in the morning, it can change in the afternoon. Or why it says 40%. Well, it's a slim chance, but the chance is still there.
Meteorologists really do try hard to predict the weather accurately because they know you use it to plan your day. It's a really important aspect of all of our lives.
Yeah. You know, Amy, thank you so much for helping me out today. I really appreciated everything that you've taught me. You did help me out with my weather questions.
It was my pleasure, Jen.
That was a great episode. I learned so much from Amy. If you have an idea on something that I should learn about next, well, let us know by leaving a comment below. This idea came to us from one of our Facebook fans, Jay. All right, well, seeing as there's no rain in the forecast, I think I'm gonna go for a swim. See you next time on Jenn Learns Stuff.